Part 8, Lipid Balance and System Restoration. Chapter 22, Resolution as the Foundation of Stability. Stability in biology is often misunderstood as the absence of disturbance, as though the healthy body is simply the body that is never challenged. That is not how living systems work. A living body is always being perturbed. Nutrients enter, metabolites accumulate, microbes make contact, tissues are loaded mechanically, hormones fluctuate, temperatures shift, sleep changes, light changes, emotional stress changes, immune surveillance continues, and small injuries occur constantly. Stability is therefore not the absence of challenge. Stability is the ability to pass through challenge without remaining reorganized by it in a defensive way. That is why resolution belongs at the foundation of real physiological stability. A system is stable not because it never inflames, never activates, never adapts, or never enters emergency programs. It is stable because it can do all of those things and still return to order once the useful phase has ended. The body becomes unstable when it can still start but can no longer finish cleanly. This point brings the entire argument of the book into focus. Membranes are not simply structural boundaries. They are the material surfaces through which the body interprets reality, stores future signaling potential, and determines whether a tissue is better equipped for escalation or better equipped for completion. Lipids are not only fuels. They are structural materials and signaling substrates that shape whether inflammatory events remain proportionate or become chronic. Omega-6 is not a villain and omega-3 is not a saint. Omega-6, heavy substrate, gives the body force for initiation. Omega-3, derived substrate, gives the body access to mediator families that help the body stop extending that force once it has served its purpose. Stability emerges only when these roles remain coordinated. If the body can initiate but not resolve, then every ordinary perturbation begins to leave residue. Thresholds fall. Membranes become easier to disturb. Tissues remain partially open, partially inflamed, partially unrepaired. At that point, instability is no longer a matter of bad luck, is built into the architecture. This is why resolution has to be understood as more than the end of inflammation. It is the process by which the body preserves continuity of self across repeated disturbance. A tissue that resolves well does not merely experience less discomfort. It remains itself more effectively over time. Its membranes are not repeatedly left oxidized and structurally confused. Its macrophages do not remain burdened with old debris. Its vascular surfaces do not remain in emergency mode. Its barriers do not remain chronically permissive. Its nervous system does not remain chemically overprotective after the actual need for protection has passed. Its mitochondria do not remain trapped in the energetics of defense. Resolution is what prevents each challenge from becoming a permanent edit to the tissue's operating style. It is therefore the foundation of resilience in the deepest sense. Without it, adaptation becomes accumulation of damage. With it, adaptation becomes recovery with preserved function. This helps explain why chronic disease so often feels like loss of stability before it looks like catastrophic failure. People usually notice this first as low-level unreliability. Recovery takes longer. Sleep becomes less restorative. Small stressors create bigger consequences. Food tolerance narrows. Exercise either feels too inflammatory or no longer produces clean adaptation. Pain lingers. Mood and cognition fluctuate more than they used to. Skin, gut joints, blood vessels, and nerves all begin behaving as though they are easier to disturb and harder to settle. These experiences are often described separately, but they are united by one deeper fact: the body is losing the ability to resolve perturbation without carrying it forward. Stability disappears when the body no longer returns fully to baseline between events. Resolution failure is what turns life itself into cumulative inflammatory burden. This is also why the modern environment is so effective at destabilizing physiology. The problem is not only that it creates more triggers. The deeper problem is that it creates more triggers in bodies whose membrane architecture, substrate balance, oxidative burden, barrier integrity, and metabolic reserve are already organized in a way that weakens completion. The person is repeatedly asked to absorb perturbation through tissues built for initiation-heavy response and underbuilt for return. That is the mechanism of fragility. Is not just more stress. Is more stress entering systems that cannot close loops well. Once enough loops remain open, even small events begin to feel large because the body is already carrying the unfinished remains of previous events. The foundation of stability is therefore not stoicism, not suppression, and not mere absence of symptoms, is the body's material ability to complete cycles. A stable vascular system can constrict, dilate, recruit, and then normalize. A stable immune system can detect, respond, clear, and then stand down. A stable nervous system can amplify protective signaling when necessary, and then withdraw that amplification once the tissue is safe. A stable gut can mount defense when barrier disruption occurs, and then restore selectivity without continuing to invite the immune system into the lumen-facing world. A stable metabolic system can handle fuel abundance and fuel scarcity without turning either one into chronic inflammatory signaling. Every one of those forms of stability is built on the same principle. The system must be able to end what it starts. This is why resolution should be placed beneath the usual categories of health rather than beside them. People often think in terms of immune health, metabolic health, cardiovascular health, brain health, or gut health as though these were separate domains with separate laws. But what makes all of them possible is the same underlying capacity, the ability to pass through activation without becoming stuck in activation. Resolution is what allows the organism to remain integrated across time. It prevents the body from becoming a collage of partially defended tissues, each carrying its own unfinished emergency into the next day. Once that is understood, the hierarchy becomes clearer. Membrane composition matters because it determines what kind of inflammatory and pro-resolving language the body can speak. Omega-3 matters because it helps stock the later phase chemistry required for completion. SPM biology matters because it turns substrate into actual instructions for closing the inflammatory loop. But stability is the deeper outcome all of this serves. The practical meaning of this chapter is therefore not merely theoretical. If resolution is the foundation of stability, then every meaningful intervention should be judged partly by whether it improves the body's ability to complete perturbation. Does it help membranes become more coherent and less easily oxidized? Does it reduce omega-6 dominance enough for omega-3 derived completion pathways to matter? Does it improve barrier control so tissues stop being re-triggered? Does it lower the cleanup burden and strengthen macrophage finishing? Does it improve mitochondrial capacity so repair can actually be funded? Does it raise thresholds so ordinary life stops being interpreted as repeated threat? Those are stability questions, and they are all resolution questions at the same time. Seen clearly, the body is stable not when nothing happens to it, but when what happens to it can be finished. Resolution is the reason biological experience does not have to accumulate as permanent alarm. It is the mechanism by which the body preserves order across repeated contact with a world that is never fully quiet. Without resolution, inflammation becomes identity. With resolution, inflammation remains a tool. That is why resolution is not just one phase of immunity, it is one of the deepest foundations of physiological stability itself. Ending inflammation restores order. Ending inflammation restores order because inflammation is, by design, a temporary suspension of normal tissue rules. During the early and middle phases of the response, the body deliberately relaxes boundaries, increases vascular access, amplifies immune traffic, alters local metabolism, raises pain sensitivity, and accepts a certain degree of structural disruption in order to contain threat quickly. That trade-off is useful when the event is acute and proportionate. It becomes damaging when the body cannot reverse it. Order is what has to be rebuilt afterward. Membranes have to stop leaking distress chemistry. Neutrophils have to stop arriving. Macrophages have to clear apoptotic cells and oxidize debris. Endothelial and epithelial surfaces have to regain selectivity. Pain pathways have to stop behaving as though the site is still under active threat. Mitochondria have to shift from emergency expenditure toward repair. Until those reversals happen, the tissue is not merely less inflamed, it is still disordered. This is why ending inflammation should never be confused with suppressing inflammatory output alone. A quieter tissue is not necessarily an ordered tissue. If the body blocks some visible inflammatory signals while leaving behind uncleared debris, unstable membranes, persistent cytokine tone, barrier leak, and low-threshold immune reactivity, then the site remains unfinished even if symptoms temporarily soften. True ending is different. It means the tissue no longer needs emergency logic to maintain control. The inflammatory state has been converted into a resolution state, and then that resolution state has done enough work to restore ordinary structure. The body stops recruiting because recruitment is no longer needed. It stops amplifying because the site no longer justifies amplification. It stops protecting in the emergency sense because the tissue has become safe enough to return to maintenance. Order in this context is not abstract calm, is physical coherence. Gradients are preserved again. Membrane composition becomes functionally useful instead of chemically unstable. Receptors stop reading ordinary inputs through a background of unresolved danger. Vascular surfaces return to controlled exchange rather than inflammatory openness. Barrier tissues stop letting the outside world bleed too deeply into immune space. Neural tissue stops signaling through persistent noise and regains precision. Metabolic tissues stop behaving as though every fuel exposure is a stress event. What resolution restores is not merely comfort. It restores the architecture that lets tissues behave according to their real function rather than according to temporary defensive distortion. This is the deeper reason specialized pro-resolving mediators matter so much. They do not only turn inflammatory intensity down, they help drive the biological work through which order is rebuilt. They reduce continued neutrophil influx, strengthen macrophage cleanup, limit collateral injury, support tissue protection, and help create the conditions under which barriers can close, membranes can stabilize, and repair can proceed without being constantly interrupted by renewed alarm. In that sense, ending inflammation restores order because resolution is the process by which the body removes the physical and signaling evidence that disorder is still justified. Seen clearly, inflammation is useful precisely because it disrupts order in a controlled way for a defined purpose. Resolution is what makes that disruption survivable. If inflammation begins and never truly ends, the body remains trapped in a half-emergency state where function is always being subordinated to defense. If inflammation ends properly, the tissue becomes itself again. That is what restored order really means. Not silence, not suppression, but the return of structure, signaling, and behavior to a state in which defense is no longer the governing principle. Energy system stabilization. Energy system stabilization is one of the clearest signs that resolution has succeeded because the body cannot remain metabolically organized while it is still spending heavily on unfinished defense. Inflammation is expensive. Recruitment costs energy. Cytokine production costs energy. Oxidative bursts cost energy. Barrier leak increases metabolic inefficiency. Membrane damage has to be contained. Ion gradients become harder to maintain. Sleep quality falls, pain rises, movement changes, and mitochondrial output is redirected towards survival chemistry instead of restoration. A tissue living in persistent inflammatory activation may still produce ADP, but it does so inside an unstable priority structure. Energy is constantly being diverted into surveillance, containment, and damage management. That is why people in chronic inflammatory states so often feel both activated and exhausted at the same time. The body is not low in activity. It is metabolically trapped in expensive activity that never reaches completion. This is where stabilization becomes more than symptom relief. A stabilized energy system is not one that simply produces more energy in the abstract, is one that stops wasting energy on repeated, incomplete inflammatory loops. Once neutrophil infiltration tapers appropriately, once macrophages begin clearing efficiently, once cytokine tone falls, once barriers stop feeding fresh provocation into tissue, and once membranes stop releasing so much distress chemistry, the body can reallocate resources. Mitochondria are no longer being asked to support a semi-permanent emergency. The tissue can begin shifting from defensive expenditure toward repair, maintenance, and normal functional output. That shift often feels like improved stamina, better recovery, more stable cognition, fewer crashes after meals or stress, and less background fatigue, but underneath those experiences is a deeper physiological change. The organism is no longer financing unresolved inflammation at the same rate. Mitochondria sit at the center of this process because they are not only power generators, they are also participants in inflammatory biology. When tissues remain inflamed, mitochondria are exposed to altered substrate traffic, oxidative stress, cytokine pressure, calcium instability, membrane damage, and repeated demand for emergency adaptation. Under those conditions, ADP production becomes less efficient and more costly. Reactive oxygen species can rise. Fatty acid oxidation may become incomplete. Glucose handling becomes less flexible. The cell remains capable of work, but the work becomes dirtier and less stable. Resolution helps correct this not by magically upgrading mitochondria from the outside, but by reducing the inflammatory burden that keeps mitochondrial function trapped in survival mode. Energy system stabilization therefore depends on inflammatory completion because the organelle cannot return to efficient output while the tissue keeps telling it that the emergency is still active. This also explains why metabolic flexibility improves when resolution improves. A poorly resolved tissue often becomes metabolically rigid. It overreacts to glucose, handles fatty acids poorly, accumulates intermediates, or swings between underpowered and overstimulated states because the inflammatory environment keeps distorting substrate use. A better resolved tissue can switch fuels more cleanly because the signaling environment is quieter, membrane transport and receptor behavior are more coherent, and mitochondrial membranes are operating under less oxidative and cytokine-driven interference. Stability at the energy level, therefore, is not only a matter of having enough calories or enough fuel substrate. It is a matter of whether the tissue has stopped behaving as though every substrate exposure is part of an unresolved threat state. Seen clearly, energy system stabilization is one of the practical outcomes of successful resolution. The body stops burning resources to hold open a process that should have ended. Mitochondria become less burdened by defense chemistry and more available for repair and ordinary function. Tissues regain the ability to produce energy without coupling that production so tightly to inflammatory distress. That is why restored energy is not a superficial benefit of resolution biology. It is one of its deepest consequences. A body that can finish inflammation well is a body that can finally afford to use its energy for living instead of for remaining half-defended. Nervous system calm. Nervous system calm is not the absence of stimulation. It is the return of the nervous system to a state in which stimulation no longer has to be interpreted through unresolved threat. That distinction matters because a calm nervous system is often described in emotional or psychological language, when in reality it is also a membrane, immune, and energy problem. Neurons, glial cells, vascular interfaces, and synaptic membranes all have to stop behaving as though danger is still present. Pain pathways have to stop amplifying. Microglia have to stop maintaining a surveillance posture that is too aggressive for ordinary life. Synaptic environments have to become less chemically noisy. Membrane excitability has to stabilize. Sleep and autonomic tone have to stop being dragged around by unresolved inflammatory signaling. Calm, in this deeper sense, is not a mood. It is the restoration of signaling order. This is why nervous system calm depends so heavily on successful resolution. A nervous system still carrying oxidized lipid fragments, persistent cytokine pressure, low-threshold nociceptive signaling, glial overactivation, and unstable DHA-dependent membrane structure cannot truly settle, even if the person tries to rest. The tissue is still broadcasting unfinished danger. The brain and peripheral nerves continue reading ordinary inputs through a background of defensive chemistry. Small stressors feel bigger. Sensory input becomes harder to filter. Sleep becomes lighter or less restorative. Mood becomes more fragile. Attention becomes less stable. The person experiences this as anxiety, tension, overstimulation, or poor recovery from stress, but underneath those experiences the biology is often the same. The nervous system has not finished its inflammatory event well enough to trust the environment again. DHA-derived mediator biology matters here because calm in the nervous system requires more than less inflammation. It requires protection of the signaling surfaces themselves. Protectins, D-series resolvins, and related later-phase signals help reduce continued inflammatory pressure, support cleanup, and preserve delicate tissue from collateral injury during de-escalation. That is essential in neural tissue because precision is the function. A nervous system becomes calm not when it is suppressed into silence, but when its membranes, synapses, glial cells, and vascular interfaces no longer have to keep operating inside a field of unresolved danger. Once that happens, sensory thresholds normalize, pain amplification can withdraw, autonomic tone becomes less defensive, and the person experiences what calm actually is at the physiological level, a nervous system that no longer needs to stay half-guarded between ordinary events. Seen clearly, nervous system calm is one of the lived outcomes of restored resolution capacity. It appears when the body can stop protecting after the useful phase of protection has passed. That means fewer lingering inflammatory signals, better cleanup of neural debris, stronger membrane stability, lower oxidative noise, and less repeated re-triggering from the rest of the organism. Calm is not passivity. It is the return of the nervous system to a state where precision no longer has to compete with chronic alarm. Hormonal normalization. Hormonal normalization is one of the clearest downstream consequences of successful resolution because hormones do not operate in isolation from membrane structure, inflammatory tone, vascular control, and mitochondrial status. A hormone can be present in circulation and still be poorly interpreted if the membrane receiving it is unstable, the receptor environment is distorted, cytokine signaling is chronically elevated, or the tissue remains metabolically trapped in defense. This is why chronic inflammatory states so often look hormonal from the outside. Cortisol rhythms become less stable. Insulin signaling becomes less reliable. Thyroid signaling becomes less effectively expressed at the tissue level. Reproductive hormones may be present yet poorly translated into stable function. Appetite hormones become noisier. Sleep and circadian signals lose precision. The body begins to look hormonally dysregulated, but in many cases the deeper problem is that endocrine signaling is being forced through tissues that have not completed inflammation well enough to return to low-noise interpretation. The membrane matters here because receptors for insulin, thyroid hormone-related downstream effects, steroid signals, leptin, and many other endocrine inputs operate through surfaces whose composition determines clustering, mobility, signal propagation, and downstream coupling. A chronically inflamed membrane does not read hormonal information cleanly. If omega-6 derived initiation substrate dominates, if oxidative damage has altered phospholipid behavior, if cytokine tone remains high, or if mitochondrial strain keeps the tissue locked in emergency priorities, the same hormone can produce weaker, less stable, or more distorted downstream effects. The body then compensates with more signal, different timing, or altered set points, and what emerges clinically is called dysregulation. But the hormone is often not the only thing that has changed. The interpretive surface has changed. Inflammatory persistence also directly reshapes endocrine priorities. In a body trapped in partial defense, cortisol and other stress-related systems remain more engaged because tissue still appears unresolved. Insulin handling becomes less stable because metabolic tissues remain inflamed, adipose signaling remains abnormal, and mitochondrial throughput remains inefficient. Reproductive signaling often degrades because the body does not invest in long-horizon anabolic and reproductive stability, while local tissues still behave as though repair and defense are unfinished. Thyroid output or tissue responsiveness may look inconsistent because the system is continuously reallocating toward survival chemistry rather than confident baseline function. Hormonal normalization, therefore, is not just a matter of producing the right hormones. It is a matter of restoring a body state in which hormones can resume governing ordinary physiology instead of constantly negotiating with unresolved inflammation. This is why resolution is so central. Once neutrophil-heavy continuation falls, once macrophage cleanup improves, once barriers stop feeding fresh provocation into tissue, once vascular surfaces calm, and once membranes become more coherent and less oxidatively noisy, endocrine signaling has a different landscape to work through. Receptors become easier to interpret cleanly. Energy availability improves because less ADP is being wasted on chronic, incomplete defense. Sleep often improves because cytokine and nociceptive tone fall. Appetite and satiety signals become less distorted by inflammatory traffic. Stress hormones no longer have to cover for constant, unresolved tissue burden. In that sense, hormonal normalization is not separate from resolution biology. Is one of the organism-level signs that resolution has become strong enough to restore ordinary command hierarchy. Seen clearly, hormones normalize when the body no longer has to keep translating every endocrine signal through an inflammatory emergency filter. The endocrine system does not become healthier by hormone concentration alone. It becomes healthier when tissues regain the structural quiet, membrane stability, and lower inflammatory tone required to hear hormones accurately again. That is why chronic inflammatory illness so often looks endocrine, and why real endocrine recovery so often depends on far more than adding or suppressing one signal. The body has to become less defended before it can become more hormonally coherent.